Oh my gosh, it's really embarrassing. We go for it.
Oh, and the case fell off. That's right.
Sorry.
Like a bad fall.
All right, let's learn. Okay. This is a lot more focused than I was thinking. Good job, you guys. That's good. I'm glad. We'll see if you guys like it or if you guys choose to not come and just watch videos. But I'm glad you guys are here. So first, what was I gonna say? Oh, I was gonna say that if you are here, then obviously you're taking the BC test. But make sure that you join the AP classroom because that's how they know when to, or like who to order the BC test for. So if you haven't joined the AP classroom, do so with those codes. But you still have a little bit of time, but still, as soon as you can. Now, let me teach you some extra integration stuff that we have to know that AB does not. Starting with this section, which you guys all have, I think. Yeah, I see it. It's 6.7, AB stops at 6.6, so you guys have a few more sections to do. And then we stop for a little while, and then you have a few extra sections in Unit 7. Then we stop for a little while, you have like one extra section in Unit 8, and then we'll go every day after Unit 8, because you have Unit 9 and 10 to learn that that AB does not. So that's the outlook. But here, you just have like 3 in a row, then we stop for a little bit. Then Unit 7, etc. Okay, and it starts first with integration by parts, which basically, if you want to know the oversimplified version, you just follow this formula that I'm pointing at right here with my mouse, and that's it. But if you don't want to know the oversimplified version, here is the whole concept behind it, is that integration by parts is like undoing the product rule. So remember, U substitution was undoing the chain rule. Integration by parts is undoing the product rule. So the idea is that, well, here, let me write some stuff down. The idea is that you can write this or you can not. But here's me writing the product rule just so I can show you how we're going to undo it. So the derivative of x times d is f times the first times the derivative of the second plus second times the derivative. So f prime times d. Okay, like that. And so to undo this, what you're gonna do is you're gonna be like, okay, in each of these parts, I see one normal function and one derivative function. So in your process, you're gonna be like, okay, what function was the first and what function was the derivative of the second? And then I'll be able to like extrapolate what the integral should be from that. So it might be easier to start with an example, and then go back to this and see how it relates, like what we just did, how that relates to this orange stuff that I just wrote. So watch this example. It says evaluate that integral. I see a product of two functions, so my only two options are either U substitution, which would have come from the chain rule, like derivative of the outside times derivative of the inside, or this thing, which is integration by parts. So maybe this product of functions came from the product rule first times derivative of the second. So since I don't see an inside function whose derivative is in there, I'm like, oh, okay, this must be integration by parts. But you guys will start to work out your little flow chart of integration. Like if I see this, then do this as you go, but just so you see, like with experience, that's what I'm thinking. Now, here's the actual process. First, you choose, like I said, you choose what your first was and what your derivative of second was. It's unfortunate that they use, like, traditionally the same letters as U substitution. Like, you'll see a U, a DU, a V, and a DV. It's really not really the same process, but they use the same letters, so try not to get that confused. But, what I was saying is, I'm gonna choose a first and a derivative of the second, which they call u and dv. That's a v, by the way. And then I'll find what vu and v are according to, like, what I chose. Okay, and then there's a right way and a wrong way to do it. Like, if you chose what should have been dv as u, then you won't make very much progress, and vice versa. So the right way to do it is usually, there's always exceptions, but usually you choose u so that its derivative is simpler. Like when you take a du, that should be like, usually it's like polynomials or stuff like that. So in this case, I'm going to choose u to be x, and that would be the correct thing. Because here's what I'm saying, when I take du, now that du is 1 dx, which is like simpler, it's one step simpler. So 1 dx turns to like dx. And then kind of once you choose your u, you kind of don't really have a choice for dv. dv should be everything else that you see in the integral. So in this case, that would be this e to the x dx. And then again, a quick way to know if you got that wrong is if you don't know the antiderivative of your dv. But in this case, this should be pretty easy. You tell me what the antiderivative of e to the x is. Yeah. Okay, right. So then my v, not my dv, but my v going backwards, antiderivative would be e to the x. I guess plus c, but I'll save all the plus c's for later. Cool. And then, like I said, once you choose these, it's kind of just following this formula. Kind of all the prep work we needed. Now we can say this integral equals, following the formula should be uv, so x times e to the x, minus integral of v du, integral of e to the x dx. Okay. And then obviously this isn't your final answer because there's still an integral in there, but this second integral that you get in, like, once you do a step should always be like doable. Sometimes you have to do integration by parts multiple times, which is annoying, but most of the time you will follow the formula once, and then this integral that I'm circling right here should be like easily doable. And that's the case right now. So the x e to the x minus integral of e to the x is e to the x. And then I put the plus c at the very end. That way I don't have to write a bunch of plus c's. Cool. All right, more intuition coming in a second. But question? Yeah, you'll see it in a second. But yeah, you'll just do the exact same process, get the antiderivative, and then just evaluate it at 2 and 7 or whatever. Yeah.
Like the straight line.
Yeah, with the straight, correct. Yeah, for the people on the video, the question was, can you do this with a definite integral? And the answer was what I said. Yeah, you can, and then you just put a straight line here and say, I'm going to plug in 2 and 1 or whatever. Nice, good question. Other cues? All right, that's basically it, and then the rest is like practice. So let me give you one more little bit of intuition, and then we'll keep going in practice. So like I said, you're undoing the product rule, and kind of the well, maybe I show you like the whole, like the whole way of getting this formula. So this formula, if you ever forget it, you're in the middle of the test. I don't think you'll forget the product rule. And then what you can do is kind of just take the integral of both sides and do some solving, and you end up with the formula. So watch this. If I see, like in this case, I'm like, oh, this looks like a product. It might have come from the product rule. So say I'm trying to take the antiderivative of f times g prime. Like that's how I'm interpreting it, f times g prime. Then what you do is you take the integral of both sides of this, dx. And I'll give you the very short version so you guys don't get bored. But take the integral of both sides of this. This is like the integral of a derivative. So you just end up with, like, they cancel each other out. Then on this side, I get the integral of f times G prime plus, let me split this into two integrals. Like instead of integral of this plus this, let me just do integral of this plus integral of that. And then here you can see where the formula came about. If I want the integral of first times derivative of second, like I said here, first times derivative of second, then I can just subtract the second integral over here. F of x, g of x, minus that second integral. So it's not really that hard of a proof to show that this, integration by parts formula works. It does not look anything like this, but if you call F U and you call G V, now you call this U and this is V, then you can see where like this would have been U, this would have been DV. When we're choosing that here, U and dV. Now that's equal to UV minus integral of this what we call V, and then F prime dx is what we call du. I don't know if that's easier or harder for you to remember, but I tend to forget like each year before I teach this, I have to remind myself of how the formula works, but I can always derive it myself. So I don't know. It might be worth your time. And hopefully you see the connection now. Like F is U, G is V. You can see where the U and dV and all that stuff comes from. Question?
Does your DV always have to be, the part that's,
Yeah. Nice. Yeah, exactly. Your dV, you're thinking as that was my derivative of second. So that would be the G prime times the dx. Oh, but I see what you're saying. Is it always going to be written second in your integral?
is it always going to be next to the DX?
No, not necessarily. I see what you're asking. No, for the people in the video, the question was, is the dV always going to be like right next to the dx? And the answer is no, not always. Yeah, no, not always. Okay, next one or more questions? All right, let's do the next one, and then even if you have questions, they'll get cleared up as we do more and more things. All right, watch this. X times sine of 3x dx. Again, I see a product. My two options are either u substitution or integration by parts, but the inside function in this case does not, like the derivative of that, I don't really see how that's going to interact with this x out here. More on that if you want later, but what I'm saying is u substitution isn't going to work here, so I know it's going to be integration by parts. So here's me saying, okay, I got to set this up, u, du, dv, and v. And I like to underline the u and the dv to remind myself, like, those are the ones that I'm choosing, and then the rest is, really the only one you're choosing is u, and then the rest are chosen for you, kind of. But okay, let's see how much you guys have taught with all the stuff I've been saying. What would you say you should be? Like, yeah, nice. Most of the time you want to make that your polynomial function, so x, and then the du would be dx. Now you know you kind of did it right because the derivative is simpler. Most of the time that's what you want. Sometimes it's not. You'll see some exceptions to that. All right, x dx, and then dv, this is the real check of if you did it right. Once you chose your u again, dv should be everything else, so sine of 3x dx. Okay, and then, like I said, this is a good check. If you can take the antiderivative of this, then you probably did it right. If you can't, then you did it wrong. So maybe without, if I don't give you much of a warning, do you know the antiderivative of that? Do you know?
Cosine for x over 4.
Hey, good job with the over 3. So the thing that's annoying about this one is that it has this inside function, so technically you have to do U substitution. But you could kind of skip the U substitution if you think real hard. So, okay, if you want to show the U substitution, do it. Here's me doing it fast as lightning, because I know that I need the antiderivative of sine of 3s. And I'm like, oh shoot, there's an inside function, so that means U substitution. And du is 3 dx. So if I solve for dx, I get the 1/3. That's where the over 3 comes from that Sam was talking about. Okay, and so now if I replace my integral, I get sine of u times 1/3 du. So let me put the 1/3 out here. And then, like Sam said, that would be 1/3 times integral of sine is negative cosine. Now let's look at the antiderivative. And then finally 1/3 cosine of 3 plus d, I guess. But what I was saying is you can kind of not worry about the U substitution if you remember that you're trying to undo the chain rule. So when you're doing the chain rule, if you just left it as cosine of 3x, then you'd have this extra 3 that you'd be multiplying by. So to undo that, you'd have to divide by the 3 here. Should have been negative. Sorry. So what I'm saying is when you're taking the derivative, you'd multiply by 3. When you're taking the antiderivative, if it's just this linear inside function, then you'll just divide by that coefficient. And I'll let you think about that yourself. Or you can just do the U substitution every time. But I think it's just easier to skip it and say I got this 3x here that if I did the chain rule, I'd be multiplying by. So to undo the chain rule, I'd be dividing by. So that's that. And this happens all the time, so it's a good trick to know. All right, but anyway, integration by parts, that prep work is done. Now we just follow the little formula, which remember was uv x times negative cosine of 3x over 3. uv minus integral v du. Nice. Okay. All right, cool. And then, like I said, you should be able to take this integral pretty easily most of the time. And that's the case this time. It doesn't look that friendly, but if you rewrite it a little bit. Rewrite a couple of things so it looks nicer. I just put this x up here. And then minus negative, let me make that a plus. And then this over 3, let me take that out like I like to do. Now it looks a lot friendlier, and then let me quiz you on what we just talked about. What would be the integral of the cosine of 3x?
Negative sine.
Hang on, now let me look. All right, what'd you say?
Negative sine.
Yeah, no, I think it'd be positive sine.
Oh.
Right? The antiderivative
Yeah.
of cosine would be positive sine. Okay. And I'm checking that you keep track of all your stuff. Sine of what is it? Nice. Over the 3, that's what we were just talking about, the 3x, and here you'd have to divide by it, because technically that's, you should do U substitution, but if you remember to divide by it, then you can skip the U substitution. All right, there you go. And then plus c, and we did it. That should be the answer to this. If you don't believe me, then you could take the derivative of this and see that you get back to that. But hopefully you do believe me. I guess we could have cleaned it up a little bit and done 1/3 times 3 is 1/9. But still, that works good. All right, and then the next one is a definite integral, like you were saying. I don't remember who asked, Jake maybe, but here it is. Okay. Okay, so watch it. Same process as before. I see a product of two functions. I don't see an inside function, so probably this is integration by parts. Integration by parts would be set up like this. I choose U, and I choose dV. And then now, let's check on you guys. What would you choose for U?
Squared.
Yeah, that's what I told you. If you're writing in pen, don't write the X squared, because that's too wrong. In fact, I guess now I've given it away. But let me show you why. Let's pretend you were doing your homework. And I just told you, you always choose the polynomial. Okay, good job. Then du would be 2x. Okay, it did get simpler. But then, like I said, once you chose your u, your dv should be everything else. And now you're thinking dv should be natural log of x dx. But what's the antiderivative of natural log? No, that would be the derivative, but the antiderivative, we don't know it. Like, that's not one of the ones we know. Like, what function has a derivative of natural log? That's what we don't know. So that's why I'm saying this is a good check. If you don't know this antiderivative, try switching your u and dv, and that should get you farther. So that's why I'm saying wrong. We chose the wrong thing. Let's try the other way. U should be natural log. Then du would be 1 over x dx. dv, again, once you choose your u, you kind of don't have a choice for dv. That should be the everything else. So that would be, in this case, x squared dx. And then v will be, you tell me, just to make sure, what would v be?
1/3 x cubed.
Okay, yeah, good job. I'm checking that you don't take the derivative, you're taking the antiderivative, x cubed over 3 plus d, I guess, but we save all that for later. Okay. And then you'll see that this gets us further, because, well, you'll see in a second. Now, prep work is done. Now I follow my little formula. This would be equal to uv minus integral of v du. And then let me worry about the bounds in a second. In fact, I just wrote something wrong, but I'll talk about that later. It's the equal sign is the thing that's, and this is not technically equal because this was a definite integral, now I just wrote it as an indefinite thing. But we'll worry about that later. Like, they would get mad at you on the AP test for that, but not me. If I was grading your stuff, I'd say that's fine. Okay, but anyway, that's where I'm at. Then let me take the full antiderivative, and then I'll worry about my bounds. So full antiderivative would look like, let me do a couple things. I'll write this nicer, x cubed times natural log of x over 3 minus, and then, like I said, let me take out the 1/3, like I like to do. And then let me, this is x divided by, well, x cubed divided by x, so one of these will cancel one of these. Now that's squared in here, dx. That's no, like, I could take that, no problem. Like, I could take that x equation. So now that would leave me with x cubed natural log of x over 3 minus 1/3 times x cubed over 3. And normally plus c, but I'm just checking if I went too fast. Are you good with these 3 steps? Okay, so yeah. Yeah, I was stopping just to check that I didn't, like, go too fast. But yeah, now I can plug in my e and my 1, and that'll be my final answer. Okay, so then this is equal to e cubed times natural log of e over 3 minus, let me combine these thirds, make it e cubed over 9. That's me plugging in the e, and then minus, here's me plugging in the 1, but I'm running out of room, so let me do it strategically. 1 cubed times natural log of 1, we just write that as natural log of 1 over 3 minus 1/9. Remember, I'm subtracting that whole thing, so put the parentheses. And that would be a fine answer to circle, or you could simplify this a little bit, because natural log of E, hopefully you guys know that, but I know a lot of you, like this is one thing that West Seattle High School doesn't do that well, is teach you the relationships between E and natural log and all that. But do you guys know the natural log of E? No. Okay, yeah. Natural log of E is 1, because they're inverses of each other. That's what the natural log is. So times 1, but I'm not going to write that. E cubed over 9, there's no nice way to write that. And then natural log of 1, hopefully you know that that's 0, and then minus 1/9. So actually that's minus negative, this is 0, and that's plus 1/9. And it's probably a nice way to simplify that, but I don't want to. I think that's as much as I want to do. 32, you guys got to leave at 40 something. Okay. We're doing good. How many more are there? 1. Art sign, and that's it. Nice. All right. Last one is a sneaky one, but you'll see this here, and you'll see it on the homework, and it's like a fancy way of getting a lot of tricky antiderivatives. But this one, you don't even see a product of two functions. Like, that's the thing that I told you to look for, but like, and you know, if you see a product of functions, it could be integration by parts. Here, you don't even see a product of functions. You see the single arc sign. But the trick is like this. If you treat this like 1 times arc sign, that's a 1 times, then there's your product of functions, and that actually gets you a lot, like that gets you the antiderivative. It's not something that you would have thought of by yourself, but once you see the trick, you're like, oh, well, if I don't see a way to make progress on this, let me try integration by parts, let me try this little trick. And a lot of times it gets you far. So watch this. Okay. 33. Okay, you guys have a little time if you want to try it yourself. Or at least choosing the U's and the DV's. So let me give you like 1 minute to see if you get the right one.
Remember the derivative of arc sine?
I sure do. It's 1 over square root of 1 minus x squared.
Maybe no.
Yeah, that rules.
Okay. Is it now? I guess you can be derivative of 1, 2, that's just 0, but it might not be like
Correct. So that would mean you probably flipped it. Yeah, it's never easy. Like, a lot of times, bro, that's just the way this goes.
or no, you're 1.
There's no, unless you have really good foresight, you do that great way.
I mean, like, if there's just like a coefficient, like this, 2 arc signs.
Do you have a job or do you do AP?
Like,
Without a job? Oh,
like, so just a coefficient in the front when you're doing one of these.
As long as it's an arc sign, then yeah, then we'll always follow this format.
Well, like, if there's a, like you said, if there's a 1, like, sometimes it's gonna just be like 1.
Yeah.
Times whatever, like, that means
Yeah.
it could be like a 2, and then you have to do like the same thing, which is.
Yeah,
like,
it would just be 2 times whatever we got here. Yeah.
Also? Oh.
All right. Well, you guys are making good progress. I don't know if I should stop. Yeah, I think so. Yeah, actually, Sawyer just reminded me that there's a process to this. So let me start it on the board. You guys can keep working. I'm proud of you. You guys made more progress than I thought. But let me start on this, and you could check your answers if you're doing it. But you should have been, without wasting your time, it should have been that U was arc sign, because otherwise it would have been dV, and you don't know the answer. So that's the whole question, is what's the antiderivative of that, so you wouldn't have gotten it. So anyway, U should have been arc sign. Then you might have had to check your notes or the internet or something, but the derivative of arc sign, we do know, is 1 over square root of 1 minus x squared. Actually, you'll see that a lot in today's normal AB lesson, unfortunately. And I guess, yeah. And then dV would have been 1, making V x. And then following the little formula, you would... Oh, yeah, no. Okay, and then following the little formula, you would get UV x times arc sine of x minus integral v du. And then, like I said, a lot of times you'll get that this second integral here in, like, as you're doing your process, this should be an easy integral. Like, now you can take that without such fancy tricks. But in this case, it's not super obvious how to take that, but does anybody see? Does anybody see how to make progress on that second integral? You see it? Legend. Yeah, exactly. Yeah, and the more you integrate, the more you'll get better at seeing this type of thing. But what Brooks saw, and anybody else who saw U substitution, you saw an inside function, and you saw the derivative of x squared is 2x. Oh, that'll take care of this x up here. That 2x will interact with that x or x. So yeah, we got to do some U substitution within our integration by parts, which is frustrating, but hopefully not super tough. Here's me going fast because we have 7 minutes left. But there's my U, there's my du. Here's solving for the dx. Here's us rewriting. And here's what I was saying, is that this x cancels that x. That's how you know you did it right. Now I get, I guess I'll do it in a lot of steps. I get 1 over, then this was negative 1/2. So let me put it negative 2 square root of u du. And then this is why I was considering doing it in all one step, but there's a lot to do. You could also put this negative out in front, which is what I think I want to do. So let me take the negative, put it in front. Now that's minus the negative, so I can make that a plus. And then some of you may recognize this antiderivative right away, or some of you may need to do a trick, but we'll talk about it after this question. Oh, I just don't like, okay. I like having the function and then du rather than du over whatever, but you're right that most people would write du over whatever. I just like having like function, du, and then it's really clear what I should be anti-differentiating. All right, and then whether you write this as 1/2 times u to the negative 1/2 and then add a 1 to the power and divide by the new power, or maybe you just recognize that this is the derivative of square root of u, the derivative of exactly equal to that. But either way, you should get final, well, almost final answer of this. And then remember, it's especially weird in this case that you have x's and u. So you want all x's, so you can go back, you can plug in the 1 minus x squared, and that's your final answer. Okay. So there you go. That's integration by parts. As you can see, it takes some practice. I know it's frustrating, but the more you practice it, the better you'll get. So I do recommend. I'm not going to check the homework for a grade because you guys, like on your transcript, it's going to say AP Calculus AB. So I don't want to give you guys extra work that's not going to benefit you transcript-wise. But it's a good idea to do the homework and get good at this. And the answer key is on Schoology, so you can check it just like any other homework. But I won't check it for a grade. Nice, you guys. All right, tomorrow, as long as it's algebra, I have an algebra 1 meeting, but I'll try to get out of it, and I'll be here for 8 or 6, 8. Yeah, 6, 8 tomorrow morning at 8 a.m.
Wait till BC tomorrow.
BC tomorrow as well. And then we have to do 6, 9 Monday, and then we're done for a little while. All right, I'm gonna end this meeting, but I'm here for questions.